All right, everybody, thanks for tuning into my video. I wanted to make a quick video about the box plot and some of the things that come along with it, including something called a 5-point summary. So let me write that on here, 5-point summary. So if you have a collection of data and you want to make some general conclusions about it quickly that are easy to visualize, this is something that you might be asked to do. And so a 5-point summary consists of 5 kind of key elements: the minimum, the maximum, the median, which sometimes you'll hear me call the middle, and then these new things that we don't have too much experience with yet, called quartiles, and specifically the first quartile and the third quartile. You can think of the median as the second quartile, but generally we never call it that. We call it the median. And what you can do with this 5-point summary is plot it on this visual that's above, and you can kind of see all the key elements just right in front of you. So the reason they're called quartiles, I wrote Q1, but comes from the prefix quarter. But what the quartiles do is it breaks a chunk of a data set into basically 25% chunks. Again, quarters, if you think about it like that. And so if you have the median value, which again is going to be kind of right in the middle, you can say that 50% of the data is below the median, below the middle. The other 50% is above it. And if you take kind of the first quarter of the data, that cutoff between the first quarter and the second quarter, that's where we'd find the quartile 1 value. And then this other thing, which again, I'll do an example here in just a moment, but the interquartile range, sometimes abbreviated IQR, you get that by taking the value of the third quartile and subtracting the value of the first quartile. Very similar to how to calculate the range, but remember the range is the max minus the min. So it's kind of similar in structure. And the interquartile range, this big mess I'm making, would represent kind of the middle 50% of the data. So let me do kind of a quick little example. It's really not too bad in terms of some of the stuff we'll cover. So let's just say we have a data set, and for time and convenience, I'm going to put this data set in order. And remember, anytime you want to find the median or the min and the max and all these things, you would have to order the data. So I'll save us the trouble and kind of give us some data in order. And so a couple things that stand out instantly is this would be the minimum, this would be the maximum, and right smack dab in the middle, this would be the median, which again you could think of as quartile 2, but it's still going to be called the median now and forever. And remember, if there was an even amount of data, right, there's 1, 2, 8, 9 pieces of data in here, so that's odd. The median kind of emerges from it. But if there was an even amount, you would take the average of the middle 2. So how do you calculate the quartiles? Well, the idea is if you take the bottom half and find basically like the median of the lower half, meaning the middle, which would kind of be right here, 5 plus 5 divided by 2. That's going to be the position of quartile 1, or Q1. And if you take the upper half the position of quartile 3, meaning kind of the 75th percentile, so to speak, would be 12. And so those 5 numbers, I'll circle them in yellow. The min, the quartile 1, the median, the quartile 3, and the max. That's what we would call our 5-point summary. And what the box plot is we want to make our box plot accurate, so we kind of have to include everything on the number line. But our box plot is essentially a visual representation of the 5-point summary. So you don't want the data to be misleading, so you want to label the number line appropriately. But to actually make the box plot, we can do a line where the minimum is, another line where quartile 1 is, another line where the median is, another line where the quartile 3 is, and the last line where the max is. And the 3 middle pieces kind of create this thing, this box. And again, that box contains 50% of the data, because each one of these hash marks is a quartile. And then sometimes it's also called a box and whisker plot, with these 2 little lines I'm drawing called the whiskers. And they represent kind of the bottom 25% of the data and the top 25%. And so the idea is if you, if I ask you to calculate the IQR, it would be 7, because 12 minus 5. If you were asked for the range would be the max minus the min, so it'd be 13. The median, again, is 7. That's right in the middle. And then other things, you could use technology for is to find the mean. There looks like the mode in this example would be 5. And so there's a lot of things that could be asked. The last thing that I'll include in this video, because I try to keep them short, is a lot of times, I shouldn't say a lot of times, one of the main things that the IQR is used for is to find what's called an outlier. And we've talked about this a tiny bit in class, but an outlier is basically a value, sometimes called an extreme value, that can skew the data. So if you were collecting data on, the heights of people or something, and you have a really tall person or a really short person, that kind of affects the mean to an extreme way, you might consider that an outlier. If you live in an average neighborhood, but you have some mansion on the corner, the price of that house might be an outlier for the average price of the house in the neighborhood. But then the question becomes, well, how big or how small does it have to be considered an outlier? And so there's kind of a formula for it, where if you find the IQR of some data set and multiply it by 1.5, it gives you kind of a value that's going to allow you to create a cushion, essentially, where if the data is inside this cushion, it's considered okay data, and if it's beyond this cushion, that's my own word, I suppose, then it's considered an outlier. And so if I go back to this last example, the IQR was 7. So if we use that last example, the IQR was 7. And if we times it by 1.5, 7 times 1 would be 7. A half of 7 would be 3.5. So you get 10.5. And so what that means is if we go to our box plot, it means that if you look at our quartile 1 position, which is 5, and our quartile 3 position, which is 12, the formula kind of works like this. If you take quartile 1 and subtract 10.5, and you create quartile 3, not create, you take quartile 3 and add 10.5. So in the last example, we had, what did we have? We had 5 and 12 as our numbers. Gotta wrap this up because YouTube's gonna kick me off. So what I get here is negative 5.5 as some kind of number, and I get 22.5. What this means as an interval, and this example was kind of good data in the sense of outliers, and my data ranged from 2 to 15. And what these numbers say that I just found is that all my data was, between 2 and 15. This was the min and the max. And what these negative 5.5 and 22.5 says that this boundary, this cushion, is if I had any values, so again, my box plot's kind of in here. Negative 5.5 is down here on the number line. 22.5 is out here. If I had any data beyond 22.5 or beyond negative 5.5, again, kind of creating this new interval, anything beyond that would be considered an outlier. So play with that a little bit. Maybe look at another example. If you need another one, I'll create another video. But hopefully you got the basics down, and I appreciate you watching. Thank you.